Now you should know that this is part 2 of the power supply series. If you have not seen part 1, I would appreciate if you would watch part 1 first before watching part 2. But anyway, this is high-speed video footage of me unwinding the original secondaries in the transformer that I would then be to use for winding new secondaries for the power supply that I'm building in these videos. Of course, the power supply is done by now and sits on my workbench where I am. If you can notice, probably hear me counting all the turns. And that's, I have to be able to know those turns to put them into that equation to find out how many turns is in the primary, to then know how many turns to wind in the new secondaries for the desired voltages. 23 turns on that particular layer. So, I don't know how many videos this series is going to be. It might only have the part 2, and that might be it. It might be part 1, part 2. Then again, it might have a part 3. I don't know yet. It'll probably fit on 2 parts.
Is the primary unmolested and insulated.
This footage was shot in late March of 2011.
The only thing is now, I gotta get the wire. Oh yeah, and work the equation.
Okay, today we're going to wind the transformer.
The red thing marks the first line.
Okay, again we have high-speed footage. This time of me winding the new secondaries onto the transformer. Quite a time-consuming and careful process with quite a few annoyances on the way when wire would spring out and not want to stay where it was wound and things like that. And then of course in the end it was a little too thick and I had to subtract some windings to even get the transformer metal plates to fit in.
I know it's going to be. It's barely too thick for Murphy's sake.
Here's some more pictures of the completed power supply, and showing some voltages and of the completed power supply with light shed on it. Here's again pictures of the completed transformer. I just want to show that again. I don't think I took any footage of me putting the cores on to the transformer. The metal pieces, I mean. Okay, here's some video. This was, of course, earlier on in the project's history. Now, some of you may have already seen this video uploaded by itself onto YouTube, but this is just a video I shot of the testing stage of the voltmeter schematic that I found on the internet, which uses the ICL 7107 chip, which is useful for making meters, digital meters. And it was built on a breadboard, and this is just some footage of me testing the thing out, and it was successful. It was done with a lower quality camera than the other one that I have. Well, I have several cameras, but This was done with a lower quality digital camera, so it's not the best video in the world, but it is good enough that you can see it pretty clear. I show a close-up of the ICL 7107 CPL chip by Intersil. That particular chip there is from the 70s, I believe. It came with a whole bunch of electronic parts I got at an estate sale. You don't find that at estate sales every day. There was a ton of the organizer drawers full of chips and resistors and all kinds of components. It was fantastic. 5 volts. And some music playing in the background. I think the video that had that song had since been, for some reason or another, who knows why, deleted from YouTube. Because I looked at my favorites one time later to find that same song, and it was missing all of a sudden.
And the power supply is going to have 2 adjustable supplies in it, and it's going to have built-in digital volt and amp meters.
What a project I have set in front of me. Now, on which board am I going to be building the power supply circuit? It's pretty easy. A lot of those parts end up being off the board, such as the regulators and the current limiting resistors. The current limiting resistors I think I'm going to put right onto the rotary switch. But then again, maybe not. I'm wondering if I want to use this board or if I'm just going to use this little board. So that might be kind of hard to get it all into this one. Now if I want to mount it vertically into the power supply, this board's too big. So this board might be a good candidate. We'll see.
Here's a little progress for my project. This is the first volt and amp meter module. I was wanting to run all the meters off of one power supply, but unfortunately that's not going to work. I probably have to have one power supply per meter. That means the voltmeter is off one, the ammeter is off another, then the other voltmeter is off a third, the other ammeter is off a fourth. But because I tried running the volt and ammeter off together, but they interfered. I had problems. Have a voltmeter and an ammeter running off separate power supplies. Right here, this is going to be how it's going to look. And the panel of the power supply is going to be 2 sets of these. There's going to be 2 meters like this, one, and then there's going to be another one just like this. Original that I was going to be doing, and I was hoping to have 2 meters off this chip, 2 meters off of the other one, but it looks like I'll have to use one power supply per meter, so I'll probably end up taking one of these chips and pair of capacitors off. It's the ICL 760. ICL 76.
Here we have it. Let's show it. And okay, volts over here, amps over here. That's for this power supply. This knob is for voltage. That knob is for current limit. Then a positive, negative. That's earth ground right there. That's a power switch. And here's the other one. Volts, amps, plus minus. Voltage control, current limit control. Pretty straightforward. This one goes up to 28.6, and this one goes up to 26.8. Huh, the 8 and the 6 are switched around. How about that? Or 26.7. But it's, these meters, I tried to set them as best as I could for accuracy, but they aren't perfect. I couldn't get it perfect. I couldn't get it precise enough to where it couldn't be accurate throughout the entire voltage range. You're supposed to, on the circuit, set the reference voltage to 1 volt, But if I do that, they're not accurate. If I set it to 1 volt, I believe the reason why is because I used regular resistors that I have this silver. What's the tolerance on that again? No, the gold, I mean, plus or minus 5% tolerance. I didn't use those really precise resistors, and I'm thinking that's the reason why it wouldn't be accurate when set to 1 volt reference voltage. But I'll show a showing of comparing with the meter to show how close they are. Okay, due to my account still having the annoying 15-minute time limit, I'm going to have to ask you to please go to part 3 to watch the remaining part of the video, and then it will be concluding the power supply series. So please go and watch part 3 of the power supply series about this power supply, and it will show the rest of the video and my conclusion message. See you there.